So as I said, we want to do a little bit about coding with maps without getting into anything that I'm going to misdirect you to think you need to use them inside of your application. So at a high level, the example object we want to talk to, I want to define that so you can see what it looks like and what we would have going on with the map at a high level. So we have a player object outside there, and the player object's not anything super special. First name, last name, the number of the player. There's not a ton that's going on that we need to do to use it as part of our data outside of the rules for either a hash code or a comparator or comparable that we would have within the specific maps. But just in general, I don't need to do anything special to deal with this. It's just any object will work. So again, we have our ability to fill a map. And so a map can be defined like any other generic with a key type and a value type from the design you have going on. So I have a map that shows I'm going to have a number, which is the player's number, and a player object. And so this is a map of the players by number. So again, I make a new hash map of this case with number and map. And then when I put it inside of there, I can take these players I created up top, I can get one of their attributes, in this case the number, and then I can throw the player object inside of it. So the map guarantees the data inside conforms to the design I want by using the generics. And we talked about that with collections, the same concept here. So I take the number from the object itself and then throw it in the map. Now I have to explicitly do that. I have to pull the object out myself. I don't have to use, in this case, an attribute, but it makes sense to. I can use any value I want to as long as I use it consistently. The other way around, I could store by, let's say, their last name. So in this case, I can put each of the values inside of there by their last name, and I could look it up by their last name, pulled out from that. So in this case, I make another map with a string there, but it could be any string. It's not guaranteed to be the last name. I could put the wrong thing inside of there if I coded it wrong. But the important thing here is I can use the data type to ensure that at least it's players being stored by a key that is a number or a string. The code there, mostly though, I want to show you, is the put method, which has two parameters, the key and then the value that's associated with that. Now, we can also, as we saw the second one in the demo before, we can create a map which has a player that points to a team object, which looks up the team for a player. Same sort of concept. Now I just have the key values, which are the full objects I'm pointing to, a player object and then a team object. And again, we use the values to ensure that I have the right types inside of here using generics. So since I have a cross-reference here, you can see player at 22, that's because I didn't do a toString on the player object, is pointing to the Chicago Bears, which is because I did do a toString on that object. You got to remember the toString is not implemented in an interesting way unless you choose to do it. And I wanted to show you that here, the example, so you can see the both of them. Whether I do toString or not, the data will be printed out in some way, but the map itself doesn't use toString. It's just a convenience method that you'd use out there. So remember, I still have to, for my objects appropriately in hash maps, use the hash code value. I have to override equals and hash code to make sure it works right. And if I don't, my map could be screwed up. If I use the tree map, I have to use the comparable or add a comparator when I create the map. And if I don't, it won't compile right, get an exception. It's just not going to work. Basically, you just ensure. So the tree maps has a little bit of help to make sure you do it right. The hash maps doesn't, because you don't have to implement hash code, in which case you could have a map that just acts funny. It might work right fine sometime, work wrong at different times. So you have to remember to do that on your own there. But as an example of that, here, if I do funny things inside of my map, if I don't be very careful with making sure my keys are appropriately done, not only in just implementing those, but how I design my keys. So I could have a new player that comes in, which is Eli Manning, which is Peyton's brother, who plays for the New York Giants. And so I have that player that comes in, and I can throw in by number, and then I can throw that into by name, and I can throw that into by team, and funny things happens to my data. So in the first one here, you can see number 18, Peyton Manning gets kicked out, and he's replaced by Eli. Now, I know Eli's not number 18, but just wanted to show you the point that it takes that value and then replaces the one that's out there. It doesn't have two of them that's out there. And the second one, last name, inside of there, the Manning becomes Eli Manning again. We kick out Peyton from that list. But down here, a little bit screwy, when I say add in the player for team, then all of a sudden, Peyton Manning becomes playing for the New York Giants. Because the way I designed my key, I did it wrong. I am not searching on enough criteria, and so I have the wrong Manning brother. I didn't implement my either comparator correctly or my equals method correctly. I wasn't looking on the whole criteria, and so I do not replace keys out there. The keys stay the same. The values change. And so I did not introduce a new Manning brother. So you have to be very careful with dealing with those keys. You have to be very careful that you implement them accordingly as you're going off and doing this code for using these maps. If you don't do it right, you won't notice. So within your equal method, when you do an override equal, and as I promised we would show that here, the equals method is an override from the object. And the first thing I normally do in the equals method is I make sure that the object I'm comparing it to is actually an instance of the same thing I am, a player in this case. And then if that's the case, I'm checking if they have the same number. Now, in football, having the same number is only a useful measure if they're also on the same team. So I would have to check something else besides for just number. In the whole NFL, two people can certainly have the same number. So I have to check number and name. Are ideally even better number, name, and team to get that out there. So I just have to be careful on how I implement this, or I could get funny behavior down the road. So how do I know? Well, you basically test it. You basically need to go through and double check, make sure it works right inside of there. But there's another way you can check inside of there, is when I go and add things in to a map, it'll actually return back to me an object if one was displaced. And so you can at least get a warning in your code if you so choose. If you're really worried about this, not sure what was going on, or just needed to know if things get displaced from a map, you can actually get the value back. You can see what I put it inside of there. We displaced Peyton Manning, we displaced Peyton Manning, we displaced the Indianapolis Colts. If you didn't mean to do that, then you can say, oops, there's a bug. Maybe I should go off and fix that. But again, we're not going to go off and build this because you're not being asked to build this in this class. I wanted to show you some code so at least you can see this, but you should have the foundation and the examples from previous weeks to go off and play with this if you so choose. If you have any questions on that, I'm glad to help you with the code. I just don't want to give a big demo and make you think you're supposed to be building it, because that's not what this week is about. But this is really powerful stuff for you to have in your toolbox to be able to go and use when you go become a coder. Maps can be really great at solving the right kinds of problems when you have them. So know what they are, and when it comes along, find a way to use them.